Okay. Today we're going to talk about the mobile robot simulation. The basic for this mobile simulation is just moving a box. It's moving a box, just like showing here, just moving this box, and this box representing a mobile robot. And then in this simulation, involve a box translation, like showing here, translation around x-axis, and then if you go around the curve, and then it involves in the box rotation and the translation. Right, so here. So how are we going to do this? The first one is for box translation. So here involves 4 steps, and the first one is define a box by 4 corners, the 4 corner coordinates, CJ. So J from 1 to 4 in the body coordinates. So these are body coordinates, x prime, y prime. You have 4 points, C1, C2, C3, C4. You define them. And then the second step is to define a body center vector, B sub 0, which is this one here. That's in global frame, so x and y. And then third, you define a bunch of waypoints, 1, 2, 3, 4, 5, 6, so on and so forth. Along the path, and that is again is in the global frame, x and y. And then all you have to do just translate the 4 corners, which are here, by adding a translation vector, which is the center vector here, and then your corner point is gonna move. Now for rotation, also involves 4 steps. And the first one is you define a bunch of waypoints. So a bunch of waypoints, but in this case, some along the straight line, some around the curve. Okay. But nevertheless, you need the translation. And then for rotation, you have to define the tangent angles. Like if you rotate, then you are at the body coordinates x prime is going to rotate, right? The x prime is going to rotate, and then the y prime is going to rotate. So you have to define this angle along the curve. So there's a tangent, the tangent angle. So the angle is at each waypoint. And then you have to rotate the corner points by using this rotation matrix. I'm going to show you in the MATLAB by this rotation matrix. And then you define these moving points, 1, 2, 3, 4, the moving points, 4 corner moving points, by adding the translation. And this one's rotated coordinates, right? So by doing so, you will move the box, and also you rotate the box. So this is the quasi codes. You can translate this one into MATLAB program. So at the beginning, you have to define the corner points, the box corner points, and the center vector. And then you have to set waypoints if it's a curved, and then you have to define the tangent angle, and you can draw the line here. And for other waypoints, and you have to go through this for loops. And if it's a pure translation, you're just adding the translation vector here. If for rotation, you have to define the rotation matrix, and then you have to do not only the translation, but also you have to do rotation, and that's original corner points in the body frame. And then you plot, basically you draw the box, and then the finish. So let's see the MATLAB program. So this is the MATLAB program. This is to follow the line a curve for the box, because I have a line, a curve. So you start with line points. So there's a total line length, and how many waypoints you want to generate, and use this command to generate the waypoints, and then plot. And then this is a quarter circle waypoint. This is on a curve, and define number of points, and then calculate the angle, and then you define the radius, and then generate the waypoints in a plot. And then now use a for loop to move the box around the line, go through all these waypoints. So of course you have to plot line again, hold on, and then you define a box that's in local coordinates, So I define 4 corner points at 1, 1, minus 1, 1, minus minus 1, 1, minus 1, and it goes back to the first one here. You 4 corner points, but you know to plot, you have to plot 4 lines. So that's why I define 5 points, to close the box. And then you had to, this is a translation one, and that is the local corner points, because there's no Y translation, so that's why they stay as original. The in Y-axis stay as original coordinates, and then you plot them. So you finish around the curve, and you plot the curve here, and we only define the angle for the here. We only define the angle for the circle, but for the tangent, you have to reverse it, right? So you have to reverse the angle, to calculate the tangent angle. So how do you calculate the tangent angle? And then this is the center point for you to do the translation. And then this is rotation matrix. Okay, basically using the tangent angle, rotation matrix, and then you rotate the box. Okay, and here basically you do the rotation, and this is the translation. And this is the same. I just the column vector becomes the raw vector, and then I just plot them. Okay, so let's see how this one works. So this is the translation. Around the curve, you have translation and the rotation. All right. So it's kind of simple. But nevertheless, you have to know how to define the translation vector, rotation matrix, combination of these two, and then you start to simulate the box movement.